Question 10. Given that 1 plus cos 2 theta plus sine 2 theta is not equal to 0, prove that 1 minus cos 2 theta plus sine 2 theta over 1 plus cos 2 theta plus sine 2 theta is equivalent to tan theta. Okay, first thing I'm going to do here is look in my formula booklet, because I can see with the cos 2 theta and the sine 2 theta, and that it's a proof question, I'm going to want my double angle formula. Now I can derive this. On my formula booklet, I have my compound angle formulas. So I can use these to find my double angle formula. So for sine, if A is equal to B, sine of 2A would be 2 lots of sine A cos A, or in our case, theta. So sine 2 theta is 2 sine theta cos theta. I can find cos, again, if B is equal to A, then cos 2A is equal to cos squared A minus sine squared A, or in our case, cos 2 theta is the same as cos squared theta minus sine squared theta. Now, with a proof question, I would typically want to start with one side. Sometimes you work from the right hand side to the left. In this case, I'm starting from the left hand side, and I want to rearrange it, making one change at a time until I get to the right hand side of this equivalence. So, starting with my 1 minus cos 2 theta plus sine 2 theta over 1 plus cos 2 theta plus sine 2 theta, I'm going to make the substitution for cos 2 theta and sine 2 theta that I derived from the compound angle formula in my formula book. So my cos 2 theta, 1 minus cos squared minus, so plus sine squared, plus my sine 2 theta, which is 2 sine theta cos theta. So having made those substitutions, I can now see on the numerator here I've got a 1 minus cos squared theta. On the denominator I've got a 1 minus sine squared theta. So I'm going to just write down my other trig identity that should be firmly in mind. My sine squared plus cos squared is equal to 1. Because this allows me to see that, well, 1 minus cos squared is equal to sine squared, but also 1 minus sine squared is equal to cos squared. So on the numerator, this 1 minus cos squared can be written as sine squared, and on the denominator, 1 minus sine squared is equal to cos squared. So this can be written as the following. This can be simplified. This is 2 sine squared plus 2 sine theta cos theta over 2 cos squared theta plus 2 sine theta cos theta. Now I'm going to actually factorize the numerator and the denominator. On the numerator, I can take out a factor of sine theta. So taking sine theta out leaves me with 2 sine theta plus 2 cos theta. And on the denominator, I can take out cos theta of 2 cos theta plus 2 sine theta. I can see that these will cancel, and I'm left with sine theta over cos theta, which is tan theta. And so I'm back on the right hand side of my equivalence, and so I have proven it. Part B, hence solve this expression is equal to 3 sine 2x, giving your answer to one decimal place where appropriate. Now, quite often these will involve part A. So if we look, these are very similar. I have my 1 minus cos plus sine, etc. However, this time I've got 1 minus cos 4x instead of 2 theta. So using my proven equivalence, I can write that this 1 minus cos 4x plus sine 4x over 1 plus cos 4x plus sine 4x is equivalent to tan 2x. Therefore, I can say that tan 2x is equal to 3 sine 2x. Remembering that tan 2x can be written as sine 2x over cos 2x, multiplying through by cos 2x. There is a misconception here that we can divide both sides through by sine 2x, But if you do that, you're ignoring the solution that sine 2x can bring. So taking the 3 sine 2x cos 2x to the left hand side and then factorizing gives me sine 2x lots of 1 minus 3 cos 2x is equal to 0. Therefore I have two factors to solve. The first being that sine 2x can be equal to 0, and the second being that cos 2x is equal to a third. Solving firstly for the sine 2x is equal to 0, 2x then is equal to sine to the minus 1 of 0. When using the inverse sine function, there are an infinite number of results. The first value given to me on my calculator is 180. I know my sine curve to repeat for 0 every 180 degrees, but I am only interested in the x values between 0 and 180, and so since the 360 would half to 180, it is outside my range, and so solving the sine 2x equals 0, I get the one solution of x being equal to 90 degrees. Solving the cos 2x, so 2x is equal to cos to the minus 1 of a third. On my calculator, that gives me the initial value of 70.52 and so on. On a cos curve, my second value will come from 360 minus this value. The term after would be 360 plus this value, but I would be then outside my range. So my 2x is equal to 70.52 and so on, 289.47 and so on. Dividing through by 2 gives me the two solutions, 35.3 and 144.7 degrees, within range to one decimal place. Therefore, the three solutions to my equation are 35.3, 90 and 144.7.